Okay, so today we're going to use integration by parts to figure out how to integrate the cosecant cubed dx. And I guess we could kind of apply the same ideas here for the secant cubed as well. First of all, we're going to look at this different, and we're going to look at it as cosecant squared times cosecant dx. And that way I can have my integration by parts, where I can let the u equal the cosecant, and I can equal the dv to the cosecant squared, because I know how to take the derivative of the cosecant, and I know how to take the integral of the cosecant squared. The integral of the cosecant squared is negative cotangent, and as I get ready to write here, the derivative of the cosecant is the negative cosecant cotangent. Don't forget about your dx. So we can start writing this whole thing over again. The cosecant cubed of x dx is equal to, and then we'll have our uv, which would be negative cosecant cotangent, minus the integral of v du, and those negative signs are going to cancel, and so I'll have cosecant times cotangent squared. And this is a little bit of a tricky problem because at first you think we're back into another integration by parts, but when you do integration by parts on that, really what happens is you end up getting 0 equals 0, and it's kind of like no kidding. So we're going to look at cotangent squared instead. We're going to use its Pythagorean identity for the cosecant squared minus 1. And so we're going to go ahead and replace cotangent squared with cosecant squared minus 1. And I'm going to go ahead and distribute the cosecant into that. So what I end up having is negative cosecant cotangent minus, and when I distribute that cosecant into that, I'm going to have minus the integral of cosecant cubed minus cosecant. And don't forget about the dx. And we can break an integral up across addition and subtraction. And I want to do that here because I'm going to end up with my negative cosecant cotangent. But then I'm going to have my minus cosecant cubed, which is nice because that's kind of what I started with. So I can kind of turn part of this anyways into an algebra problem. And then I also have plus, because I want to distribute that subtraction sign, plus the cosecant of x dx. And remember again, that's what I started with, the cosecant cubed of x dx. And so part of this just turns into a basic algebra 1 type problem where I'm going to add my cosecant cubed to both sides and end up with 2 of them. And you can see on the right side, those cosecant cubes, those integrals, those cancel out. And on the left side, I have the 2 cosecant cubed of x dx. And then what I end up with is equals to negative cosecant cotangent plus the integral of the cosecant. And that becomes our new problem here. This is actually 2 problems in one. How in the world do I integrate this cosecant of x? And really what we got to do here is we have to manipulate the way we look at cosecant of x. And I know this seems kind of made up, but what you're going to do is you're going to multiply numerator and denominator by the quantity cosecant x plus cotangent x. And it's kind of a neat little tool for us to use here, because what ends up happening so both numerator and denominator by cosecant plus cotangent. That's pretty nice here. And what's going to happen is when I distribute the cosecant into that numerator, I'm going to be left with cosecant squared plus cosecant cotangent. And in the denominator, I end up with cosecant plus cotangent. And if you look closely, what you realize is that this problem actually turns into a basic u substitution problem where I can let u equal the entire denominator. And when I let u equal the entire denominator of cosecant x plus cotangent x, then what I end up with is the derivative of that, the du part, ends up being just the negative of the entire numerator, because the derivative of the cosecant is negative cosecant cotangent, and the derivative of the cotangent is negative cosecant squared. And I can factor a negative sign out of each of those, and I get the entire numerator in the expression we just kind of created there. So it literally turns into an integral problem where I just have to integrate negative du over u, and I know that integral, that's the negative natural log of u. And when I go back and replace this, I'm going to get negative natural log of the absolute value of the cosecant plus the cotangent. And that is how we find the derivative or the integral of the cosecant. We would apply the same idea here if this was the integral of the secant as well. But anyways, we're going to take this here, our evaluation of the integral of the cosecant, and we're going to go ahead and plug it back into our original problem. And then don't forget, we still have to, how do I get back here? Yeah. There we go. And so we'll plug this back in, and then remember we still have an algebra problem here. And so I am going to have to divide both sides by 2 to kind of solve for this integral of the cosecant of x dx. And so I'm going to end up with the integral of the cosecant cubed of x dx is equal to negative cosecant cotangent minus the natural log of the absolute value of cosecant plus cotangent. And all of that is going to be divided by 2. And then I can just make sure I add my constant of integration. Pretty tricky problem here. This same kind of concept would be applied to the integral of the secant cubed as well. I hope this helps. This is a ton of math, but I'm sure you guys are doing great.